The AI you're using right now is measurably worse at basic tasks than it was 6 months ago, and the people building it know exactly why. This isn't a conspiracy theory. Researchers at Stanford and MIT have been tracking this for months, and the data is public. GPT-4 used to ace math problems and coding challenges. Now, it fails way more often. Claude handles reasoning tasks differently than it did last year. Gemini's getting inconsistent. And it's not because the companies are lazy or cutting corners. It's actually something way more interesting and honestly kind of unsettling. So let me break down what's really happening, because this affects anyone who uses AI for work, learning, or building things. First, the thing you need to understand. These AI models aren't like software that gets better with patches. They're trained once, frozen, and then deployed. So when you ask me why GPT-4 is worse now than in March, the answer isn't they broke the code. The answer is way weirder. The main culprit? Instruction creep. And I mean that very literally. When OpenAI, Anthropic, and Google release their models to the public, they don't just release raw AI. They wrap it in layers of instructions, what researchers call alignment or safety training. These are basically guardrails that tell the model, don't help with illegal stuff, don't generate hate speech, don't make up facts, be helpful and harmless. Sounds good, right? Here's the problem. Those guardrails keep getting thicker. Every time a model does something embarrassing or dangerous in public, the company adds more rules. Every time a news story breaks about AI being used badly, another layer of caution gets baked in. Every time a user complains the model is too woke or refuses to help, the company tweaks the instructions again to try to balance being helpful with being safe. But here's what actually happens. The model gets paranoid. Let me give you a concrete example. Ask GPT-4 in late 2023 to write a simple Python script that scrapes a website. It would do it, no problem. Totally legal, totally normal programming task. Ask it now, and it'll hedge, warn you about ethics, maybe refuse outright. The model hasn't forgotten how to code. It's just been told, over and over, be careful, be careful, be careful, so many times that it started refusing legitimate requests. The same thing happens with math and reasoning. The model gets trained to double-check itself, to say, I'm not sure, to avoid overconfident answers. These sound like good things in isolation. But when you stack dozens of these instructions on top of each other, the model starts second-guessing itself on straightforward problems it should nail instantly. There's actual research on this. A team at UC Berkeley tested GPT-4 and found that as companies piled on more safety training, the model's accuracy on standard benchmarks actually went down. Not by a ton, but measurably. It's like you taught someone to be so cautious they freeze up when making simple decisions. The second thing driving this is something called reward model drift. These companies use human feedback to train their models. They hire people to rate which answers are good and which are bad. But here's the thing. Different humans have different opinions. One person thinks a model should be cautious and admit uncertainty. Another thinks it should be confident and direct. One person wants the model to refuse anything edgy. Another wants it to engage with hard topics. So the company tries to build a reward model that captures what good means. But that reward model is trained on human feedback that's often contradictory. The result? The AI gets pulled in multiple directions at once. It can't optimize for all those conflicting goals, so it ends up worse at everything. It's like trying to please everyone in the room. You end up satisfying no one. There's also something way more mundane happening. The models are being overtrained on feedback. Imagine you're learning to draw. Your friend gives you feedback, you adjust, you get better. But if you obsess over every piece of feedback and keep tweaking the same drawing, you might actually make it worse. You'll start second-guessing good parts, overcompensating for minor flaws, losing the original intent. That's happening with these models. Companies are running multiple rounds of fine-tuning based on user feedback, and at some point, they're just adding noise. Now, here's what's wild. The companies know this is happening, and they're actively debating how to fix it. Internally, there's this constant tension. Engineers want models that are powerful and capable. Safety teams want models that are cautious and refuse harmful requests. Product teams want models that feel personable and engaging. And all those goals are pulling against each other. Some companies are starting to experiment with letting users adjust the strictness dial. You can tell the model to be more helpful and less cautious, or vice versa. That's a partial solution. Others are trying to separate the base model from the safety layer, so you can get raw capability when you need it. But here's the uncomfortable truth. You can't fully solve this problem without making trade-offs. If you want a model that refuses everything potentially dangerous, it's going to refuse some things that are actually fine. If you want a model that's maximally helpful and capable, it'll probably help with some things you'd rather it didn't. You can't have a model that's perfectly safe and perfectly capable at the same time. Not yet, anyway. The other thing happening is that these companies are running into the limits of their training data. Large language models are trained on huge chunks of the internet, everything written up until a certain date. But they're not getting better by training on more internet. They're getting better by training on better data or different data. And better data is harder to find, more expensive to curate, and sometimes conflicts with safety goals. So companies are starting to use synthetic data, data generated by their own models, to train new versions. But there's a problem. If you train a model on data that was generated by a less capable model, you're basically teaching it to be less capable. It's like photocopying a photocopy. Each generation loses some quality. This is actually a real concern that researchers are studying. It's called model collapse, and it could explain some of the performance drops we're seeing. So where does this leave us? First, the AI you're using is not broken, and it's not stupid. It's just being pulled in multiple directions by conflicting goals, and that's creating genuine trade-offs that nobody's figured out how to fully solve yet. Second, this is probably temporary. Companies are aware of the problem, research is happening, and there are solutions being tested. The next generation of models will probably be smarter about how they balance capability and safety. Third, this matters because it affects what you can actually do with these tools right now. If you're relying on AI for critical work, coding, research, analysis, you need to know that it's not as reliable at certain tasks as the marketing might suggest. You need to verify its outputs. You need to be the check on the system. And fourth, this is a preview of problems we're going to see a lot more of as AI gets more powerful. How do you build systems that are both capable and safe? How do you align them with human values when humans disagree about what those values are? How do you maintain quality as you scale up? These are the real questions, and they're way more interesting than, is AI going to kill us all? If you want to actually understand what's happening with AI, instead of just reading the hype, subscribe. I break down this stuff every few days, and this is the kind of thing you won't see anywhere else.